Hello and welcome to TidyX episode 155. TidyX is a screencast where we go through and explain how our code works. My name's Ellis Hughes.
My name's Patrick Ward. Thanks for checking in with us at TidyX. As always, be sure to hit that like, subscribe button on the YouTube channel, drop the questions and comments down below. They might turn into a future episode. You never know. And as always, if you enjoy our work, we enjoy producing it for you. And we do have a Patreon page, and any donation is always greatly appreciated. That said, we're jumping into episode 155. We
155.
started this talking about functions based on a user question. And was talking about our packages based on a user question, which was how do you get data from the web and turn it into your own package? So we did that over the past 3 episodes. Now we're going to create our own package that's going to utilize our own functions. And this is really cool because a lot of times at work, you might find yourself doing things over and over every day, or every week, and in which case, just write a function for it. And if you have a whole bunch of functions, you might want to just put them into a package. So it's in a self-contained environment. You show up at work, you load that library in, and all of the things, all of the functions that you might usually use are there for you to get going with. So we're going to write some functions today, and then over the next episode or two or three, we're going to talk about how to throw them into a package, document them, and make it accessible to the world.
And make it super shareable so that you can use it yourself. You can change versions. So if you want to add new functions over time, or change the behavior of functions, it's very easy to roll back or know like, hey, are you using package version 1.0 or 1.2? And be able to correct any issues with that, because there's no such thing as bug-free code. It's just how good is the code, or does it work in as many situations as you want. So by also versioning it, there's a lot of benefits, as well as not. It doesn't just help yourself by turning these functions into a package. It's going to help your team if you can all work from the same set of functions, that you all don't have to refigure out how do I derive this one variable every single time, and having it shared across multiple people. You have a standard way of approaching it. That way you already solved that problem. You don't have to think, how do I calculate this value? How do I we're going to be talking about deriving some Bayesian values. So how do I go and do that? It's okay. Your team has already figured out how to do this. All you need to do is apply it.
The other thing before we jump in about working with a team and having a package that runs all these functions is that it makes debugging a heck of a lot easier, because if, let's say, you have a team of 5 and everybody always has to rewrite the math to do the thing, it makes it a lot, there's a lot more degrees of freedom there, where someone can forget a plus sign or add a multiplication sign instead of a plus sign or something like that. And all of a sudden you're getting all kinds of weird values that aren't reproducible. And so the important thing with this is we have one contained place, and we can ensure that we're reproducible. We can debug it if we come into errors and things like that.
Yep, exactly. So let's jump into this TidyX 155. So we're going to load the Tidyverse package as well as the Lawman package. So the Lawman package is for the data that we're going to be using, and the Tidyverse is for basic data manipulation needs that we're going to be using in our functions. We're not doing any plotting, but we're still going to set our theme to be theme light, because that's just what we do. We're going to create a lowercase batting data set by taking the batting data set from Lawman, filtering to keep any year after 2010, deriving a batting average based on hits and at-bats, and then keep player ID, year ID, at-bats, hits, and batting average. Same sort of idea with teams. We're going to create a lowercase teams object. This is going to be based on the teams data from Lawman. We're going to filter to keep everything after 2010, calculate runs per game, and keep year ID, team ID, games, runs, and runs per game. So now I'm going to run that before I forget. And now we're going to jump into how do you write a function? What is the value of a function? And how should we be approaching this? So generally, functions, the way that I like to think about them, they're really useful for encapsulating ideas. How big that idea is can vary. You can have a function that does a number of different things. You can have a lot of little functions. I tend to prefer a lot of little functions because it makes it more composable. But sometimes you don't want to have to write all those functions together. So you can have functions that are implementing other functions. So there's a whole mess of different things you can do with that. But overall, when you think about a function, say, given this input, given an input, you'll get some sort of specific result out of it. You don't want to have a function that does one thing based on one input and another thing based on another output. That makes it really difficult to understand what the function is doing. So really you want it to have a very specific result that you should get from that. Now that isn't like the same value, but you should get a value from that. It should give you the alpha value that you're deriving, or it should give you an object. So like when you use ggplot2, you're going to get a ggplot object out of it. You can also use a function for side effects. And I put some asterisks next to that because that can actually get really complicated and changes your environment. And that's kind of an advanced topic that we're not going to touch on. We're talking more about how can I write a function to derive a value for me. Next, when you write your function, it should be independent. There should not be anything that's defined outside of that function that it's using. So you don't want to, in your global environment, define some value that then you use inside of your function, because that makes it, again, as kind of Patrick alluded to earlier, makes it really difficult to understand what's going on in that function if it's referencing things that are outside of it. So again, you want your idea encapsulated together, and if you need a value from elsewhere, pass it as an argument. So the general way that you define your function, and this is in an R package or in your scripts, is you have function name, so it's whatever name you gave it, left assignment, function, so this is a preserved word in R, and then within the parentheses, you pass some amount of parameters or arguments. So I kind of shift depending on what I'm calling them. But they are a set of parameters separated by commas, indicating these are values that I'll be passing into my function. Then you have the function body, which is using those parameters that you pass to it to derive some value, create an object, create a side effect, and then it might return that value or object for you. So that's kind of high level how you might look at a function. Let's go into an actual useful example. Patrick, do you want to take us through that?
Yeah, so in episode 100, and we're gonna call back to episode 100 and 101, where we were doing our kind of series on simulation and Bayes and things like that. And two of the things that we did was we utilized a beta distribution for a beta binomial model, and we used a gamma distribution for a gamma Poisson Bayesian model. And one of the things that we needed to do was empirically derive the alpha and beta parameters for those two distributions. So those two distributions have alpha and beta parameters, which define the center and the shape of the distribution. And so we needed to define those from some empirically observed data. So we're going to write the math into functions so that it's super easiest for us to do. We can call it whenever we need. So the first function that we're going to write is called the get beta parameters function. It's very clearly named. It's telling us what we're doing. We're dealing with the beta distribution. The function takes in two arguments. It takes in a population average and a population variance. And then from there, inside of the body of the function, we have the math that calculates for us the alpha parameter and the beta parameter, and then returns those two values in list format so that we can call them independently if we need them downstream for any sort of work we're doing. So if we go ahead and we run this function, it's now in our working environment. We're just going to grab a population average from the batting data, and we're going to grab the population variance from the batting data. So there it is. So we have 256 basically, and a variance of 0.001, which once we take the square root of that, we get a standard deviation of about 3 percentage points, 0.03. If we take our function and we pass the population average and the population variance arguments in, we get two alpha and beta parameters. And the way these work, for a little sanity check to make sure we did this right with the math inside of our function, the way these work is that the alpha parameter divided by the alpha plus beta parameter should return to us the population average that we saw. So for example, if we hit, we store those two, and if we were to do beta alpha prior, which is 43 point whatever 4 5, yep, divided by the BA alpha prior plus BA alpha beta. We should see that we're going to get, there we go. We get the same average return back to us. We get the population average. So those two parameters are being used to define the population average. That's exciting. So now moving along, we're going to want to be able to use a bunch of functions to do some of our work, which we'll be showing in the upcoming episodes, but we're building the functions now. And the first one is, once we have an alpha and beta parameter, how do we get the mean, which is what we just did by hand. We'll be able to do this with a function instead of having to always do it by hand. So we create beta mu. Similarly, we create beta standard deviation, which is going to calculate the variance and then take the square root for us. So again, we don't have to type out that ugly expression by hand all the time. So if we run those two functions and we pass our alpha and beta parameters, as you can see, we get returned to us the population average and the population standard deviation, which we derived above empirically from our data.
Yep,
Cool.
exactly. And then we've got some functions that we're going to be deriving our posterior distributions from as well, correct?
Correct, which we're going to use in our vignettes, later on down the road, because you can see that these functions have more more arguments, right? So they're not just taking in a prior alpha and a prior beta, they're also taking in n, so some level of exposure or observations, and then successes, some level of times where we saw a person successfully do the thing. And within that function, within those functions, which we'll get into when we start loading this into a package and building a vignette, and then doing all kinds of fun stuff like building distributions and graphs and charts. You can see inside the body of those functions that there's a little bit of the math going on there to combine the observed information, the n and the successes, with the prior beliefs of how we believe the population behaves, knowing nothing, right? That's our prior. And so that was the beta distribution. Like I said, in episode 101, we did gamma Poisson. And this is exactly the same type of work here. The idea, though, is for a Poisson distribution, it's some level of counts of an observation over a period of time. So, for example, in this example, we're going to use something like runs per game or something like that. So again, we clearly name the function, get the gamma parameters, and we're going to pass into the arguments of that function population and population average and population variance. And the math is a little bit different in the body of the function, but it's generally the same type of approach. We return the results as a list. And then if we go and we take our team's data set and we say, hey, get me the mean and the variance of the team's data. So we have a mean, a variance, so we have a mean of 4.42 runs per game on average with a standard deviation of about half a run per game. So we can use the population mean and variance and put them into the arguments of our get gamma parameters. And then we can store those. Because we stored them as list, we can call them with the $ there. So we pull them right out. And again, just like we did with the beta distribution, we're going to get a gamma mu and a gamma standard deviation function, which do the math for us. So now we should get, there we go, 4.42 and 0.234 are going to be our mu and standard deviation using the RPG alpha prior and the RPG beta prior. And then below this, we have a little bit of application of these functions, which again, we're going to bake this stuff into vignettes and things like that. But the idea here is that, all I did was take a random sample of 10 individuals and I show, hey, this is how we use those posterior functions to combine the priors with the n number of observations, which is at bats, and the number of successes, which is hits. Like all the math is going to be done here for us. And what we see is we see a batting average and then we see a posterior batting average. So in some way, the individuals are all shrunken towards the mean based on the number of times we've seen them do the thing. For example, the third batter there who batted once and had no hits, we believe that until seeing further proof, it's probably an average hitter. They've only had one at bat. Even with the individual who had 0 at bats in row 7, they have obviously a batting average of nan because 0 divided by 0 is not a number. but that doesn't mean that we don't have an assumption on who they are. And until further evidence, we believe that they're an average player. And then up above, we do the same type of thing, applying our functions with the team's data. So we can run that. Again, we're just applying those posterior functions now. So we're taking in new information of the alpha posterior and the beta posterior, and that kicks out a posterior mean and standard deviation for the team. Again, shrinking them towards the population average. So for example, in row 3, Baltimore Orioles in 2010, they had 3.78 runs per game. And what we're doing there is basically they're getting pulled up a little bit towards the mean. So maybe the assumption is that they're probably a true 3.85 runs per game team. Whereas if you look at someone like Boston or Atlanta either one, Boston in 2010, we see that they had a staggering 5 runs per game. Maybe we don't believe their true ability is that high, but it might be closer, pulled down towards the mean of maybe something like 4.98 runs per game
Almost
with
5.
some level, yeah, almost 5, with some level of variance or uncertainty.
Yeah.
Right.
So yeah, the idea is here is that we are going through, these are functions that we are going to be turning into our R package. So we will be taking these, but we thought now would be a good time to explain how they work, explain where they came from, explain how we use them, and all of this sort of information will be captured in the R package. It isn't something that you need to have watched this wonderful screencast to understand. The idea is that we will be able to take all this knowledge, all this information that we gave you, and put it into an R package. So you just come across the TidyX Bayes package, and you know that if I use gamma mu, this is how I do it. You don't have to have watched the screencast to do that. Of course, we'd love for you to continue to watch, but the idea is that it shares and disseminates the knowledge a lot easier.
Yeah.
So with that, I think we're going to call episode 155 of TidyX. Thank you all for joining. As always, my name's Ellis Hughes. You can find me on various social media sites at Ellis_Hughes.
And my name is Patrick Ward. You can find me on X.
X.
At OSP Patrick. You can find the both of us on X at tidy_explain. tidy.explained@gmail.com is where you can email us. But best way to hit us up, like and subscribe on the YouTube channel. Drop your questions, comments down below. And as always, we do have a Patreon page. We're appreciative of anything that you'd like to donate. That said, that's episode 155 on writing functions.
Thank you all so much, and keep on exploring your world.